talk about Pluto, and that's one of the largest Kuiper Belt objects, but actually there's a whole interesting story behind Pluto. And it goes all the way back, really, before the discovery of Pluto even, back to the early 19th century, when they had noticed that the orbit of Uranus, which had been discovered sometime earlier, had a slight perturbation in it. So it had a little bit of a wiggle in it. And so what they realized was that meant there must be something else bigger or as big out there that was tugging on it. And so what they did was they did a search and they found Neptune. In the early part of the 20th century, Henry Norris Russell, a famous American astronomer, was looking at the orbit of Neptune. And on the left here, you can see Neptune, and you can see the orbit here. That thing going around there, that's Jupiter. The red lines in orbit of Neptune, these things flashing around on the inside, that's the inner planets right there. And so it gives you an idea of how far out Neptune is. And so Henry Norris Russell was looking at the orbit of Neptune. Now, he thought it had a little wiggle in it. And so he figured there must be another planet further out. And so that led, this was about the 1920s, that he thought there was a wiggle there, and that led to the search for another planet. So they temporarily called it Planet X, an unknown planet beyond Neptune. And now, turns out modern astronomers do not notice an orbit or perturbation in the orbit of Neptune. Now, the problem apparently seemed to have been a miscommunication. In America, what we did was, when we measured positions of the orbits of the planets, we did so relative to the sun. In Europe, a lot of orbits were being measured relative to Earth, and then astronomers would later do the calculations to show relative to the sun. But the difference was that the astronomy was very young science in the U.S., and we didn't fully understand that the Europeans were measuring things differently. So if you compared the old measurements of the orbit of Neptune, and there were no American measurements in the old measurements, they were all European measurements measured one way, to the American measurements that were measured more recently, then there looked like there was a shift in the orbit. And so he thought that was due to another object that was out there. Well, there wasn't. There was no other object out there, but that did not stop them from looking, because they didn't realize the mistake at the time. And so on February 18th, 1930, Clyde Tombaugh happened to discover in two photographs that were taken sometime apart an object that moved slightly. And there it is down here in the lower left. So these two photographs were taken at different times, and that object down in there was shifting. So at the time, they were able to figure out a couple of things about it. One was that it was a long ways from the sun. It was not moving very fast. And so because it was not moving very fast, you could calculate the synodic period of it. From the synodic period, you could calculate the sidereal period. And then using Kepler's laws, which y'all have done in lab plenty of times, you could figure out how far away it was from the sun. And so that led them to believe it was a very large object. Now, we've already talked about how Pluto's orbit is really very, very tilted or inclined with respect to the ecliptic. And so right here, the orange line shows the ecliptic, and they always assume planets would be a few degrees from the ecliptic. And so that's the only place they were looking for planets. Okay, now Pluto is very tilted orbit, so it's very rarely near the ecliptic. It's only near the ecliptic when it's in the part of its orbit that crosses the ecliptic. Well, in 1930, it happened to be very close to the place in its orbit where it was crossing the ecliptic. In fact, it was only for about a decade or so that it was actually close enough to the ecliptic that a search along the ecliptic would have found it. And that just happened to be when Clyde Tombaugh was looking. So he just called it purely by accident that it happened to be near the ecliptic. Had it not been near the ecliptic at that time, it's very much unlikely that it would have been found, because no one was looking for something far from the ecliptic. And so that was the deal here. Okay, now at the time that they found it, they only knew. So measuring what we could about Pluto and its position in the sky, they were able to figure out the orbit, the synodic period. From that, they could find out the orbital period and then the semi-major axis between 39 and 40 AU. That makes Pluto really far out there. At the time, they only knew about two kinds of worlds: small rocky planets and large gas giants. If Pluto were a gas giant, it would be visible in the telescope as something more than a dot. It'd be a small disk of some sort. Well, no matter how big of a telescope they used, all they got was a small dot. So that meant that Pluto was almost certainly not a gas giant. The only other thing they knew about at the time were rocky worlds: Mercury, Venus, Mars. If it were rocky, rocks don't reflect that much light, and so that meant that it probably had to be close to the size of Mars. So that put it in the realm of planets. They later discovered several things about it. They discovered it was not a rocky world. The surface, once they had the ability to measure the spectrum, they were able to find out the spectrum was very much that of ice. This was an icy world. Ice, instead of reflecting about less than 10% of the light that hits it, ice reflects like over 90% of the light that hits it. So that meant this was a much, much smaller world. So this thing was tiny, about the size of Alaska. The orbit turned out to be very weird. Rather than being fairly circular like most of the other planets, it had an eccentricity of 0.25. That means that at closest to the sun, it got actually closer than Neptune to the sun, and at farthest distance from the sun, it was almost 50 AU out. So this was a huge thing. That definitely puts it into the Kuiper belt, and that sort of started changing the discussion about what is Pluto. And so once the discovery of it came about, they realized after a number of years it was much smaller than they thought. Well, in the meantime, they'd already named it. They had a competition to name it. And Clyde Tombaugh was given the opportunity to submit his ideas, but he also was agreeable to the idea from the IAU that maybe others should be able to submit ideas as well. And a schoolgirl in submitted the winning name, and she decided that Pluto would be a good name, after the Roman god of the underworld. Okay, the idea being that Pluto, the planet, would be really far from the sun, and so always really in darkness. And so that became the name of it. When I started teaching astronomy, was right away indicating that Pluto didn't fit because the orbit didn't match that of the other planets, and so it really didn't seem to fit with the other planets. By that point, we knew it was tiny. It didn't fit with the other planets. It only stayed on the list of planets because it was put on the list of planets originally by mistake, because they thought it was bigger than it was. And so it stayed on the list of planets for the bulk of the 20th century, primarily, from a mistake. But the basic feeling was, well, it's the only thing like it out there, so even though it probably doesn't belong on the list of planets, we'll just leave it on the list anyway. Then they discovered things bigger than Pluto, and that's why it got kicked off the list eventually. Pluto's mass is tiny. It's only got about 20% of our moon's mass. And nearly 4 Plutos can fit inside of the moon with room to spare. The composition is virtually identical to that of comets, again suggestive that this is a Kuiper belt object out here. And the orbit is very eccentric. It's very elliptical orbit, and it's inclined by an enormous amount. So here's graphics here showing the orbit of Pluto, kind of an oblique view onto the solar system, showing how elliptical the orbit is, and then a side view showing it how tilted it is. And this is, of course, why even though it crosses the orbit of Neptune, it never runs into Neptune, because it's crossing the orbit of Neptune when it's down here somewhere, and so it's nowhere near Neptune. The interesting thing is that Neptune's gravity has actually grabbed Pluto and has pushed it in a 2-3 resonance, meaning that Pluto goes around twice exactly for every 3 orbits of Neptune. Again, that keeps the two away from each other. So again, another reason it doesn't really belong on the list of planets, because Neptune has basically cleared things from its orbit, and Pluto is one of the things it cleared. Okay, and threw it into an orbit here that is got this 2-3 resonance, so it'll never really come near Neptune. And so, so again, this is kind of like Earth did with the asteroid Cruithne. And so that again, this relates to Pluto as a minor body in the solar system.